right, how's everyone doing this morning? Hope you had a great weekend. Let's see who answered up on the whiteboard. We got Alyssa up there, Evangelina, Umeza, Anthony, Jasmine. Awesome, everyone. So it looks like we have the right idea with the brain stretch this morning. Let's go ahead and confirm what we already know. Yes, compounds are different atoms that are bonded together. We'll learn more about that today and specifically how we name those. Let's not get too ahead of ourselves. Just to review the other definitions here, an element is something that's made up of all the same type of atoms. So think of something like oxygen or gold. We can even extend this to something like coal or a diamond because those are just different forms of just pure carbon. Matter is all physical substances that have mass and volume. So anything that's a compound or an element in between, it's just all matter. Um, Protons, they are the part of the atom that's positively charged, and they determine the identity in the nucleus. So something that determines if it's an atom of hydrogen or an atom of carbon, right? They will have different protons. So let's move on to some disclaimers as always. All right. Please do not share any personal information during class. Your participation is required. And just reminding you that these sessions are recorded for learning purposes. So welcome to the beginning of week 6, everyone. We're officially almost halfway through here. Day 24 of 60. Fresh start of a brand new unit in our course. Let's see what we're dealing with. So unit 3 is going to be all about bonding. Now, bonding, as we can probably tell by these pictures, is something that deals with connecting atoms together, kind of like they're like Legos or building blocks that make up the real world. We'll also be starting a new Unit 3 project. We'll be dealing with different types of bonds, but today we will be dealing with specifically chemical formulas. So we will learn how to use chemical formulas to indicate the composition of a compound and explain the difference between a compound and an element. All right. So we do have the tabs up. Let's go ahead and open our notes and raise our hands.
All right, yes, remember that if you do your notes at any time during the trimester, you do get notes credit, but if you also want attendance, notes and attendance, then you need to go ahead and get your notes done during class. So go ahead and open up those links. Go, go, go. All right, looking at everyone, that looks awesome. Let's go ahead and tell me in the chat, what are some school-appropriate abbreviations that you use when you are texting or online? Go ahead and tell me in the chat. What are some school-appropriate abbreviations that you use when you are texting or when you are online? We'll talk about why this is relevant in just a few moments, but go ahead and get as many as you can in the chat. Yes, OMG, oh my gosh, LOL, laugh out loud, FR, for real. Welcome to Class Creek. Make sure you open up your notes. IYK, if you know, you know. There we go. IKR, I know, right? IDK, I don't know. LMAO is not school appropriate. What's DWD, Shane? Tell me in the chat. GTG, got to go. Got to go. BTW, by the way. Oh, D. Okay, so D. Don't worry about it. Don't worry about it. Awesome. BRB, be right back. FYI for your information. Excellent. Any other ones that you can think of? That's a lot of them. I think you all are the most prolific of our courses so far. Of our classes so far. TTYL, talk to you later. TMI, too much info. TBH, to be honest. Yes. Any other ones that you can think of? I know most of these, so I'm glad I'm not too far behind y'all. Oh, yes, /S for sarcastic. I know that one. Serious. IDC, I don't care. What you saying, Jasmine? Seriously. ALR, what is ALR? Tell me in the chat. IK, I know. Oh, it's all right. Okay, so it's literally just a truncation. All right. ALR, all right. Suspect. Cool. All right, looking good, everyone. All right, so the reason I want to talk, well, let me talk a little bit about the history of phones, in case your generation isn't familiar. But yeah, what do you mean? WDYM, what do you mean? Cool. All right, so when cell phones first came out and became popular, they originally came in this kind of brick form that you see up here. And this brick form only had a number pad. So we did have texting back then, although you got charged per text. So you could get like 50 texts a month. And if you went over your 50 text limit, you had to pay a buttload to pay for all of those extra texts. So texting was expensive. And in addition to that, when you texted, you only had this number pad in order to text. And so it was a little bit more complicated to text on here. So for example, if I wanted the letter L, which is the third letter on the number 5, I had to press the number 5 3 total times. So I had to go 555 to get to the letter L. So that is why originally this texting became so this text speak became so prolific during my generation, during when cell phones first came out, because it was really hard to text on phones. It took forever to send a text message because you had to click each number a whole bunch of times. Yeah, exactly. And if you missed it, you had to start back over. So if you pressed 5 4 times, then you had to try again to get to the letter L. So it was really annoying. And in addition, most of our text messages could only fit a few characters. So, like, if you think about how Twitter originally, right, only has a few or you can only have, 140 characters? Well, originally, text messages were even shorter, right? So, not only were they short and expensive, but they also took a long time to type out. So that is why text speak became so popular, because that way we didn't have to, like, write everything out. That way we could save money and it was a lot faster. So we use abbreviations all the time. You just proved this to me. You just showed me all the abbreviations that you know. And abbreviations are also important in chemistry. So let's go ahead and talk about how they're important in chemistry as well.
And take a look at what chemical formulas are. So a chemical formula is used to abbreviate which elements are in a compound. So it's kind of like a series of letters and numbers. The subscripts, or the small bottom numbers directly after each element, indicate how many atoms there are of that element. So if there is no subscript after an element, that means there's only one atom of that element. All right. So if, for instance, our example of the H2O right here for water, the O has no subscript, which means there is just one atom of O per molecule of water. The subscript 2 tells us that there are 2 atoms of hydrogen in one molecule of water. H2O, 1 atom of oxygen, 2 atoms of hydrogen. Let's look at, the blank always means 1. Let's look at for our notes. So for number 2 in our notes, the formula, the three answers in order are going to be formula, bottom, and 1. All right, so enter those 3 answers for number 2 and raise your hand when you are done, and I will give us a timer, and then we will move on.
All right, perfect. So we've been talking about compounds versus elements so far. Let's go ahead and talk a little bit more about this in depth. So again, compounds are actually made from elements bonded together. And when these elements bond together, they begin to act totally different from what they were originally made from. So compounds have completely different properties from the elements that they are actually made of. Let's take a look at sodium chloride, for example. So sodium chloride is NaCl. All right, remember that abbreviations can have 2 letters, a capital and a lowercase. So if you have a capital and a lowercase, you know that all counts as a single element. Smiley faces emojis in the chat box if that makes sense. Smiley faces emojis in the chat if that makes sense. Okay, so Na counts as a single abbreviation, specifically of sodium. All right, and there's no number after sodium, so a blank means how many sodiums. Blanks mean what? Blanks mean what? This is your third blank you just filled in on the previous question. Yeah, blanks mean 1. Again, they don't mean 0. If it meant 0, we wouldn't even put the letters in the first place because that would be silly. So blanks actually mean 1 in chemistry, right? So if you multiplied it by 1, it would still be itself. So sodium has 1 sodium. All right, same thing with Cl, capital C, lowercase l. That counts as chlorine. There's no number after this double letter abbreviation. So again, that also means there's 1 chlorine. So 1 sodium, 1 chlorine, making up sodium chloride. Now, sodium by itself explodes in water. We've seen this before, that when you add sodium, which is an alkali metal, to water, it begins to fizz, it begins to spark, it begins to light on fire. Chlorine, all right, is a gas, and it's a yellow gas. It's also a poisonous gas at that. So sodium, chlorine by themselves have really intense properties. However, when they bond together, they're going to create something that acts totally different. Let's go ahead and take a look at their actual process of bonding. I'm going to go ahead and share this with you up on the whiteboard.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
Yeah, isn't that awesome? Tell me in the chat, what are some observations that you made? Whenever we watch a reaction, we should talk about the observations. So tell me, what did you see happen? Good parts. Well, it started with a gas, right? So it started with that yellow chlorine gas. And then we had the metal, sodium. Yeah, and then as soon as we added that water, which started the reaction, it became like an explosion, right? We saw lots of heat. Yeah, that's why they put sand at the bottom, exactly, Shane, because that way it didn't crack the gas. It absorbed some of that heat. Yep, it kind of went big boom, and then it shrunk back down. Absolutely. We saw fire. Yeah, there was no reaction until we added that water. Absolutely. All great observations here. But the point is, when you see these really violent things happening, right? Explosions or fire or color changes, that's usually a pretty good indication that there's actually a chemical reaction happening, and chemically something is changing. So we're forming a compound, we're forming a compound in this instance. Let's go ahead and take a look at what that compound is. So when sodium and chlorine bond together, they create sodium chloride, which is just what? Tell me in the chat. This is something that you eat every single day. This is something that you eat every single day. You need it in order to survive. Your body could not function without at least a small amount of it. Yeah, this is table salt. Exactly. Now, again, it's still made from sodium chlorine, but it's acting totally different. Tell me in the chat, does salt explode when it touches your mouth? Again, your mouth has water in it. So does it explode like sodium by itself when it touches your mouth? No. So salt is not explosive like the original sodium. And salt, also tell me in the chat, is it poisonous? Yes or no? Is it poisonous like chlorine? No. So it's neither explosive, neither poisonous. It's also not a gas like chlorine. It's also not a liquid like it's not a gas like chlorine. It's actually a what? Salt is actually a what? Tell me its state. Yeah, it's a solid, right? So it's acting completely different from its individual elements. Green checks, orange checks as if that's beginning to make sense. When elements bond into compounds, the compounds can act totally different. They have completely different properties, which is really important because otherwise salt would kill us much faster than how salt is already killing us. Right? 20. You understand. Excellent. All right. Let's go ahead and fill in question number 3 and raise our hands. The first blank is different. Compounds have different properties from their elements. And the second blank is salt. Again, sodium and chlorine react and create something totally different called salt. You have 20 more seconds to raise your hands. Capitalization does not matter, but spelling does. So another example here, let's go ahead and talk about hydrogen and oxygen. Hydrogen and oxygen are both gases and they are both flammable. Think about, for example, when you light a candle, if you put the lid onto the candle, what happens to the flame? Tell me in the chat. If you put a lid onto the candle, what happens to the flame? Yeah, it goes out, right? It extinguishes. That is because fire does need oxygen. So if you put a lid onto that candle, it uses up all the oxygen that's left over. And once the oxygen runs out, the flame goes out. It suffocates, just like you and me. Flames need oxygen. Similarly, hydrogen is also flammable. Think about the Hindenburg disaster that we talked about last unit, right? We said that during the Hindenburg disaster, they used hydrogen instead of helium. Hydrogen being flammable, whereas helium is not. And so that made the disaster doubly bad because not only did the Hindenburg crash, but it also lit on fire, which probably increased the casualty count. So both of these are flammable gases. However, when they react, they form regular old H2O or water. And tell me in the chat, is water flammable? Yes or no? Can we light water on fire? Can I stick a match into water and it lights on fire? No, so water is not flammable, again, acting totally different. And additionally, it's not a gas. Water at room temperature is a what? Water at room temperature is a what? Yeah, it's a liquid. So not only is it not flammable, but it's also not even a gas. Now it's a liquid. So again, just by bonding, we're creating something that acts totally different. I always like to show these reactions just because I think it's important for you to get familiar with different reactions occurring and what they can look like. So let's go ahead and take a look at hydrogen and oxygen reacting.
When the two gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons. Closer inspection of the inside of the container shows water vapor condensed on the cool container walls.
All right, tell me in the chat, what did you observe here? I'll go to my favorite part. What did you see happening here? It does look like lightsabers, doesn't it? I had a student say that last trimester as well. Yeah, so we saw that it actually, like the explosion, the pop happened so quickly that it actually blew out the fire, right? So that was interesting. So it blew out the fire as well as, yeah, we see bright lights. We heard a pop, right? And we saw a result of this new chemical. We saw the water being formed. We saw this water being formed on the edge of the container. So those are all indicators that, again, we are creating something that is chemically different. And again, the whole idea here is that chemical compounds act different than their elements. This is the answers to number 4. Again, hydrogen and oxygen by themselves are gases that are flammable, so gases in blank 1. But water, once they react, is non-flammable. It's also a liquid, liquid in blank 2. This is number 4. Please raise your hands for number 4. Go, go, go. 10 more seconds. All right, thank you, Joshie. All right, so let's go ahead and talk about this. So sulfur dioxide is a toxic gas. It's the smell of burnt matches, which I kind of like, but obviously we shouldn't smell a lot of burnt matches. It does get released naturally by volcanoes. However, it is an air pollutant. So when you have fossil fuels that are contaminated with other sulfur compounds and you burn these fossil fuels like coal or gases, they will produce sulfur dioxide, which is not good for your body. It's also not good for the environment. So let's go ahead and break down the elements that are in sulfur dioxide. So sulfur dioxide is SO2. So you can see I have no lowercase letters, so there's no double letter abbreviations here. There's only single letters. So there's a capital S, capital O. I'm going to go ahead and share this with you up on the whiteboard. We need to identify what these are. We're going to use ptable.com. You should be very familiar with ptable.com. Tell me in the chat, what is S? What is S? What does S stand for? I'll go ahead and click on it from ptable.com. What does S stand for? Tara, Jordan, yes, S stands for sulfur, so we know SO2 has sulfur in it. And what does O stand for? What does O stand for? Again, a single O. That's going to be different than if I had a capital O with another lowercase letter. Yeah, single capital O is oxygen. Again, there are double letter abbreviations. For example, capital O, lowercase s would be osmium, right? So you need to pay attention to when do I have a single letter abbreviation versus when do I have a double letter. Double letter, though, the second letter will always be lowercase. All right, let's go ahead and jump back over to our playlist and talk a little bit about actually applying that, right? So in here, I have sulfur. Let me go ahead and type that in. So we have S is sulfur. and O is oxygen. And now we need to figure out how many of each are in here. So taking a look here, we need to look at the subscripts after the abbreviations. Again, here we only have single letter abbreviations, so looking after the single S, there is a blank, and blanks mean what? Blanks mean what? Thank you, Tara. Thank you, Jasmine. Thank you, Colleen, Rosa. Make sure you know how to do this because you will need to be able to do this on your own in just a few slides. Yes, blanks mean 1. Again, they don't mean 0. If there were 0 sulfurs, we just wouldn't include the sulfur here. So therefore, how many sulfurs are in sulfur dioxide? If there's a blank after, that means there's how many sulfurs? Tell me in the chat. Yeah, there's exactly, still 1. So 1 sulfur. How many oxygens then are in here? How many oxygens then are in here? Again, take a look at the subscript after the abbreviation. Yeah, so we have a single letter abbreviation. We have an O, and the subscript after it is a 2, and therefore there are 2 oxygens. This is the answer to number 5. You do not need to fill in the elements. That's already been completed for you. You do need to fill in the numbers. Please do not spell them out. So the first blank should just be the number 1. The second blank should just be the number 2. Do not spell them out. So don't spell out like ONE or TWO or anything, just the actual numbers. You have 20 seconds to fill out number 5 and raise your hands. Go, go, go. Work fast. We only have 10 more minutes and still a few slides to get through.
Ethylene, it has the formula C2H4. So if we go to start this over here, periodic table, what does C stand for? What is the C? All right, so very good. So now what does the H stand for? The H should be a little easier. Excellent. So going back here, carbon, all right. So now if we look at the formulas in front of the C, how many atoms of carbon do you think are in this compound? All right, very good. So 2. And then finally for hydrogen, how many atoms of hydrogen do we think are in this compound? Exactly. I love all the participation. So yeah, 4 atoms of hydrogen. So ethylene is a colorless and flammable gas. It has a faintly sweet smell and is released by fruit and increases the rate of ripening. However, ethylene has a very important use in our daily lives. It is chained together in a process called polymerization and is used to create something called polyethylene. If you want to sneak peek into organic chemistry, poly just means many. So is a chain of many ethylene compounds together, and the plastic that it makes is usually made to package stuff. So think plastic bags, plastic wrap, the plastic wrapper on a candy bar, maybe something like that. All right, and the good news about this is that because it is made from a gas that is given off by plants through that ripening process, that it is possible that this can be biodegradable or recycled from dead or decaying plant matter. All right, so let's, for number 6, let's go ahead and write down number 2 in the first blank and number 4 in the second blank and raise our hands for number 6.
All right. All right, let's go ahead and take a look at acetic acid, CH3COOH. Acetic acid is the chemical found in vinegar. Keep in mind that all of your food is chemicals, so you don't need to be scared of chemicals. You are chemicals, everything around you is chemicals, and your food is chemicals. And again, vinegar is the chemical acetic acid. Now this one gets a little bit more complicated because you'll notice that you can actually see some of these elements are happening twice, which can happen in chemical formulas. The reason why is a little bit more complex and has to do with organic chemistry, but we can still figure out how many of each element is in this chemical formula. So let's go ahead and take a look here. Tell me in the chat really fast. We should already know this. What is capital C the abbreviation for? Again, this is a single letter abbreviation. There's no lowercase. Capital C is carbon. What about capital H? Again, it's a single letter. We don't see any lowercase letter after it, so this is just hydrogen, yes. And capital O is what? Capital O is what? Yeah, capital O is oxygen. Now, after each abbreviation, which in this case I only have single letter abbreviations, so this isn't too hard. All right, if I had double letters, I would put it after the double letters. After each single letter, though, I'm going to go ahead and identify the blanks, and in each blank, I should be filling in what number. Blanks mean what? Blanks mean what? Yes, Colleen, Rosa, Tara, Julianne. Blanks mean 1. We should know this by now. If you don't know this, you're going to struggle on the next slide, so make sure you know this. Blanks mean 1. So this time we need to do a little bit of addition. So I can see a C1 here and a C1 here. So 1 plus 1 equals what? We need to add these together. 1 plus 1 equals 2 carbons. There are 2 carbons in total. Smiley faces emojis in the chat if you feel comfortable with that. Smiley faces emojis, yeses in the chat if that makes sense. You actually have to add them together. Cool, let's try hydrogen. So I can see a 3 next to this first hydrogen. Again, a blank or a 1 next to this hydrogen. So add those together. 3 plus 1 equals what? 3 plus 1 equals what? Yes, we actually have 4 hydrogens. And last but not least, I've got an O1 and an O1. Add those together. How many oxygens are there? Yes, 1 plus 1 should give me 2 oxygens. This is the answer to number 4. First blank is 2. Second blank is 4. Third blank is 2. You do not need to fill out the element names. Again, do not spell out the numbers. Just put in the actual number digits. You have 30 seconds to fill in number 7. Go, go, go. All right, so for our last question here, this last one you need to complete on your own. I'll go ahead and I'll work on one of them together with you, the one I think is probably the hardest, and that is phenol. Phenol is C6H5OH. Again, we do see H's twice here, so let's go ahead and take a look here. After the O, there is a blank. Blanks mean what? Blanks mean what? Blanks mean 1. So we have a 1 after this oxygen and also a 1 after this H. So tell me in the chat, how many carbons are in phenol? How many carbons are in phenol? Yes, there's 6. There's a 6 that comes after carbon. So that means it's either the third answer or the fourth answer. What about hydrogens? There's a 5 and a 1. So adding those together, that equals how many hydrogens? Thank you, Sophia, Jasmine, Eva. Also 6 hydrogens, right? So that could still be option 3 or option 4. What about oxygen, though? How many oxygens are here? Again, there was a blank after oxygen. Blanks mean 1 oxygen. So the only possible answer here is the fourth option for phenol. So make sure that you fill that in correctly. Yours might be scrambled, so make sure you read it closely. This is number 8. You have 30 seconds to work on number 8 for the rest of these. If you need help, we're in the Q&A area. Otherwise, raise your hands. 25 seconds. If you submitted your quiz, still raise your hands. That way it's less confusing for me. 20 seconds.
And we explained the difference between a compound and an element. All right, so just for a quick minute here, just tell us how you think you feel about this lesson. All right, awesome. Pause that. And if you haven't already, please submit your notes. Tell us how you did. I already see some of you are giving yourselves a pat on the back there. All right, cool. So, yeah, great job. Awesome, Mesa. Yeah, if there's anyone that needs to stay behind because they missed a question or they need some help for a couple minutes, go ahead and stick around. Everyone else that doesn't need any assistance, go ahead, move on to the next class, and have a great day.